Okay, this is direct variation quick video. You might want to write the notes for this in your mini lesson section as we begin to talk about direct variations. Here's a definition for you. This is also going to be in your textbook. If you look at direct variations, it's a function in the form of y equals kx. So you need to have direct variation, y equals kx. Okay? K cannot be 0. I'm going to take you through a few samples here. K is going to be the constant of the variation, and the coefficient, you should know that word. It's the number that comes in front of x. An equation is a direct variation if the graph passes through 0, and the equation can be written in the form y equals kx. When it says is a graph that passes through 0, you're going to have your xy axis, and it's, going to go through the point. This is not calibrated very well, but it's going to go through the origin of your graph. Okay? So what is actually a direct variation? A direct variation is when you have two variables, and as one value increases, the other value increases, and as one value decreases, the other value decreases. We'll use an example for Caleb Schwank. Okay? Direct variation. If the temperature rises in the summertime, what do you think happens to the ice cream sales at Pinky's? They're also going to go up. So as the temperature increases, so does the sales of ice cream. Okay? It's snowing today. There was probably 2 or 3 inches of snow on the ground when we left school. As the snowfall increases, what do you think happens to the selling of salt or shovels? They're also going to increase. That's why all stores move them to the front. On a sunny, hot, humid day in July, are we going to be selling a lot of winter mittens? No. Okay? So as we get into it, we'll talk about that with indirect, but it's direct. If one value increases, so does the other. That's directly related. It's direct variation. Here's how those graphs are going to look. Notice the green, the yellow, the red, and the blue graphs all go through the origin. That's when we said it has to go through 0. Okay? You might want to write an example like that in your mini lessons. All right, so is an equation a direct variation? Take the equation and solve for y. So we subtract 5x, okay? And then you divide by 2, and you get y equals negative 5 halves x. Is it in the form y equals kx? We have a y, we have an x, and we have a number in front of k. Oh, that's not what I wanted. Okay, what about that same equation? 5x plus 2y equals 9. Okay, did the same thing, but now we have this. Is that in the form y equals kx? Nada. So what was the difference between that equation and this one? Notice in our first one, it equaled 0. In our second one, it equaled 9. So, if it equals 0, it's going to be a direct variation. If it doesn't, it won't. Let's look here. Well, this, how can I, remember I'm trying to get y equals, divide by 7, y equals 2/7 x. Is that in the form y equals kx? Absolutely. So it's a direct variation. What if we're given a point and we need to come up with the equation? Oh my goodness. This ordered pair has an x and a y. So I substitute 4 in for the x and -3 in for the y. And I solve for y. Here you go. Y equals -3/4 x. All these examples are in your textbook also. Okay? That concludes our direct variation video.